Let's talk about the invisible engine that runs, well, everything. You probably remember it as a subject you had to cram for in school, but trust me, it's so much more than memorizing formulas. It's about understanding the code that builds reality itself. We're talking about chemistry, and today we're going to see how it powers everything from your breakfast to your phone battery. So think about this for a second. Baking a cake, charging your phone, and fighting a disease. I mean, they seem totally unrelated, right? One happens in the kitchen, one's all about your tech, and the other is happening in a high-tech lab. And yet, there's a single, fundamental science that connects them all. Any ideas what it is? You guessed it, the common thread is chemistry. And it's not just another class you have to take, it's often called the central science for a really good reason. It forms the bridge between all the others. But before we get into why, we need to get a handle on what it actually is.
At its heart, chemistry is the study of stuff. Seriously, everything you can touch, taste, or smell, that's matter. So chemistry is the science that asks the big questions. What is this stuff actually made of? How does it behave? And, maybe most importantly, how can we change it? This is basically the rule book for that invisible engine we were talking about.
And this is exactly why it gets that cool nickname. Chemistry isn't some lonely island, it's a massive bridge. You see, the laws of physics, they govern how atoms interact. And chemistry is what describes those interactions, which then create the complex molecules of biology. It's the foundation for making new medicines and for designing new materials in engineering. It truly connects everything.
Okay, so that's the big picture theory. But where is this invisible engine in your daily life? Let's follow the trail of chemistry from the moment you wake up, and you'll see it's constantly working for you, a lot of the time in plain sight.
Let's start in the kitchen. When you bake a cake, you're not just following a recipe. You are running a delicious experiment. The heat from the oven kicks off a chemical reaction in the baking powder, which releases these little bubbles of carbon dioxide gas. That's literally what makes the cake rise and get all light and fluffy. You're a scientist in an apron, trapping a gas inside a solid. Okay, now wander over to your medicine cabinet. Every single pill in there, from a simple painkiller to a life-saving antibiotic, is a little marvel of chemistry. Each one is a molecule designed with a very specific shape to fit perfectly into a target in your body, just like a key fitting into a lock to go in and fix a problem. And get this, even cleaning is pure chemistry. Soap molecules are like these tiny double agents. One end, the head, absolutely loves water. The other end, the tail, loves oil and grease, so the tail grabs onto the dirt and the head lets the water just wash the whole thing away. It's an awesome chemical trick we use every single day. And what about just getting around? Whether it's the controlled explosion of gasoline in your car's engine or the controlled flow of ions in your phone's battery, it's all based on the exact same idea, storing a huge amount of energy in chemical bonds and then releasing it exactly when we need it. So, as you can probably tell by now, chemistry is a massive, massive field. And because of that, chemists have to specialize. You can think of it like a team of doctors, right? You've got a heart specialist, a brain specialist, and so on. Well, let's meet the 5 main specialists on chemistry's team. Here they are. The 5 main branches are organic, inorganic, physical, analytical, and biochemistry. Each one gives us a completely different lens to view the world of matter, and when you put them all together, they give us the whole picture. So let's break down what each specialist does. All right, the first 2 are usually talked about together because they're kind of like 2 sides of the same coin. Organic chemistry is the chemistry of carbon, and since life as we know it is carbon-based, this field covers things like plastics, fuels, food, and, well, us. And inorganic chemistry, it's basically everything else. All the metals, minerals, salts, and glass, the building blocks of the non-living world. Okay, so physical chemistry, this is the rule book. It's a blend of physics and chemistry that asks the really deep questions. Why does a reaction happen in the first place? How fast does it go? And how much energy does it release? For instance, a physical chemist is the one who studies exactly how a battery turns chemical energy into electricity. So, if physical chemistry is the rule book, then analytical chemistry is the detective. Its entire job is to identify what's in a sample and exactly how much of it is there. And this is absolutely critical for, well, for everything, from quality control in a factory to investigating a crime scene. Here's a perfect example. Think about a medical test. When a doctor checks your blood sugar, that is analytical chemistry, live in action. A machine is performing a super precise measurement to answer 2 questions. What is in your blood, in this case glucose, and how much is there? That number you see on the screen? That's a medical diagnosis completely powered by chemistry.
And finally, that brings us to biochemistry. This is where we study the chemistry of life itself. Biochemists get to explore the incredible molecular machinery that makes all of us tick. Everything from how our bodies turn a slice of pizza into energy to how DNA writes the literal code for our existence. It's amazing.
Okay, so we've defined chemistry, we've seen it in our daily lives, and we've met its team of specialists. Now let's bring it all home and ask the most important question of all. Why does any of this matter?
So, we're right back where we started with this really simple definition. But after everything we've just seen, hopefully these words have a bit more weight to them. You see, chemistry isn't just the study of matter, it's the science of change. By understanding the fundamental rules of how things transform, we get the power to shape our world, to invent new medicines, to design sustainable energy, and to create materials we can't even dream of yet.
Understanding chemistry means you're not just learning science, you're getting a look at the operating manual for reality itself. So my final question for you is this. Now that you can see the invisible engine working all around you, what part of your world are you going to look at in a completely new way?